Good day everyone, you are welcome to GeoGIS Solution Tutorial channel. In this video, I want to show you how to calculate topographic roughness factor in ArcGIS. By the way, topographic roughness factor describes how the shape of terrain, its hill, ridges and surface irregularities affect environmental processes such as runoff, erosion and microclimates. In hydrology and geomorphology, for example, rough ground tends to slow water flow, increases turbulence, and promote infiltration. In soil science, higher roughness often means more protected zone where sediment and organic matter accumulate. So, topographic roughness factor is typically derived from measurement of elevation difference over a specified scale. So in this video, I'll show you practically how it is calculated in ArcGIS. Let's get started. In ArcGIS, I have this digital elevation model. The first thing is to make sure that your digital elevation model is in projected coordinate system. To verify that, right-click your digital elevation model and click on Properties. Then come to Source, and if I scroll down, you can see the spatial reference system. Here is geographic coordinate system. So the first thing we are going to do is to project these coordinates. So to project it, come to Search and search for Project Raster. Click on Search, and here is it, Project Raster. This will open the Project Raster tool. Then come here, the Input Raster. I'll click on the drop down and select my digital elevation model. Then the Output Raster, I will navigate to my working folder. So I will name it as Dem Projected. Then I'll click on Save. The Output Coordinate System, I'll click on this icon. I'm going for Projected Coordinate System. Click to expand it. Come to UTM. Scroll down and come to WGS 1984. The study area I'm working on belongs to Northern Hemisphere, so I'll expand Northern Hemisphere, and the data belongs to UTM Zone 32 North, this very one. I'll click to select it, then I'll click on OK. So you can see it has been captured. Then I'll click on OK. This will project the coordinate system of this data. Yes, the projection is done. But as you can see it, if you run projection or any analysis and it's looking like this, so you need to put it in stretch. So what do I mean? Come to the layer we have just projected, right click and click on Properties. Then come to Symbology. See, it is a unique value, so you need to put it at stretch. I'll click on Stretch and click on OK. So you can see my digital elevation model that I've projected. And if you want to verify the projection, right click and click on Properties again. Then come under Source. You can see that it has been projected. This is the projection we chose. So click on OK. Now after we have projected our digital elevation model, the next thing for us is to fill this digital elevation model to remove any artificial sink in it. To do that, come to Arc Toolbox, come to Spatial Analysis tool, come to Hydrology, and here is the tool called Fill. Double click to open the tool, and our input surface raster is going to be our projected digital elevation model, and our output, let's name it as Fill Dem. Then click on Save and click on OK. This will run and fill all artificial sink that might be found in this digital elevation model. Yes, the dam has been filled. Now the next operation is to calculate the focal statistics, and the focal statistics you are going to calculate involve focal mean, focal minimum, and focal maximum. So to do that, still under spatial analysis tool, come to neighborhood, click to expand it, and you can see focal statistics. So double click to open the focal statistic tool. Then our input raster is going to be our field digital elevation model. So I'll input field digital elevation model, and our output, the first statistics we want to calculate is focal mean. So I'll click on save. Then scroll down and come to this statistics type. So the first one we want to calculate is mean, so that is focal mean. So leave other thing at default and click on OK. This will run and calculate the focal mean for this very digital elevation model. Yes, the focal mean has been calculated. Then the next statistics you want to calculate is focal minimum. So come back to this focal statistics tool, and then our input raster will still be our field dem. Then output, let's name this focal minimum. Then click on save. Scroll down and come to this statistics type. So it's going to be minimum. Then click on OK. This will calculate the focal minimum for this study area. Yes, the focal minimum has been calculated. Now we are going to calculate the last statistics, which is focal maximum. Come back to this focal statistics tool. Then our input will still remain our field digital elevation model, and our output this time around is going to be focal maximum. Then click on save and scroll down and change the statistics type to maximum. Then click on OK. So it will calculate the focal maximum. Yes, the focal maximum is calculated. Now it's time for us to calculate the topographic roughness factor. Now to calculate the topographic roughness factor, we are going to make use of raster calculator. And to do that, under spatial analysis tool, come to map algebra, and then here is raster calculator. Double click to open it. So the topographic roughness index, here is the formula. Topographic roughness factor is equal to focal mean minus focal minimum. So I will introduce bracket here, put bracket here, all divided by, open bracket, focal maximum minus focal minimum, close the brackets. So this is the formula for topographic roughness factor. Topographic roughness factor is equal to focal mean minus focal minimum, all divided by focal maximum minus focal minimum. Then our output, let's name it as our topographic roughness factor, and then click on save. Then click on OK. This will calculate our topographic roughness factor for this study area. Yes, here is the topographic roughness factor. So let me uncheck this. So I can close this page. Now what I can do is to change the symbology. I'll right click and come to properties. Then I will click on classify. Click on yes. Then I can choose number of classes as 5, and I'll change the color ramp to any color of my choice and click on OK. Yes, here is the topographic roughness factor for the study area. and if you look at the value, it usually ranges from 0 to 1, and in this case it ranges from 0.1 to 0.8. So in essence, this is how to calculate topographic roughness factor in ArcGIS from digital elevation model. If you have further clarification or question, let's know in the comment section. Thank you for watching.